This next section will be pretty short, but I wanted to keep it short because it's pretty complicated. I'll cover two other aspects that affect image quality. This is what this entire section will be about. Density changes have different effects with different bit settings. Color space does not. Color changes have different effects in different color spaces. Density changes do not. I'll show you a test of the effects of bit depth on banding. We'll start with this plain image. I added a really strong vignette created in the raw software to show how clean that is. Then I dabbed a spot with the burn tool in Photoshop to study the banding that can happen along the edge of a tool when we drastically alter the density of a flat area. In this and the next 16-bit image, there's really no problem. Notice that this sRGB rendering looks the same as the previous ProPhoto version. But when we switch to 8-bit, bad things happen. That dabbed area shows some really nasty banding. Changing the color space didn't alleviate that problem, so a low bit depth is the culprit for banding. Now let's turn our attention to color rather than density. These images show that neither the color space nor bit depth matter as long as the image isn't altered. So now let's drastically shift the hue of this saturated image and see what happens. Bit depth doesn't matter. But color space does matter. The rest of these images repeat that finding. So, if you're dealing with smooth areas like a studio background or a blue sky, you want to be editing in 16-bit. If you're working with very strong colors, you should be in a wider color space like ProPhoto or Adobe 1998. Here's a graphic to show the coverage of the various color spaces. As small as sRGB is, it's really sufficient for printing because color paper covers about the same area as the sRGB color space.